Today, Borobudur is viewed as a pinnacle of ancient architecture, a static, perfectly realized triumph in stone. But the structure is actually the result of a near-catastrophic engineering crisis. Early on, the entire monument began shuddering under its own weight. The 8th century builders intended for the temple to resemble a giant lotus flower. This was a geo-spiritual design, where the tiered structure would appear to emerge from the surface of a sacred paleolake. Geological surveys from the 1990s confirmed the physical presence of this water body. Researchers analyzed surrounding riverbeds and found deep deposits of black clay containing the pollen of marsh plants, like lotus and sedge, proving this area was an active wetland during construction. This wasn't a standard construction site. The architects were attempting a massive integration of masonry and nature, placing a heavy monument into a soft, volatile wetland basin. The first major risk involved the temple's core. Unlike standard temples built on flat ground, the builders encased a 15-meter-tall natural bedrock hill entirely in cut stone. Enclosing it required stacking 50,000 cubic meters of andesite, generating an immense gravitational load pressing down onto the dirt inclines. The sloped bedrock acted as a ramp, and under the sheer mass, the heavy stone walls began sliding and splaying outward. The attempt to physically dominate the natural topography nearly triggered the total collapse of the temple before it could be completed. During a restoration project in the 1970s, architect Jacques Dumarsais conducted a forensic analysis of the stones. He found that Borobudur was not built following a single, unbroken master plan. To prevent a collapse, the builders executed 4 to 5 distinct phases of emergency redesign. This floor plan reveals how they added layers and rings to stabilize the shifting mass. The constant threat of failure forced the builders to adopt their geometry in real time. They widened terraces and adjusted alignments, compromising the ideal symmetry of their original mandala design. The structure we see today is the physical record of those desperate structural corrections. The most extreme correction required sacrificing the temple's original lowest level. This hidden base contained 160 intricately carved panels depicting the Kamadhatu, or the realm of earthly desires. Architectural analysis reveals that the decision to bury these panels was a functional necessity. The builders needed to reinforce the lowest tier to keep the entire structure from disintegrating. They constructed a massive stone retaining wall, known as a battur. By piling hundreds of tons of extra stone around the perimeter, they were clamping the sliding base against the bedrock hill. Evidence of this emergency remains on the stones today. Some hidden panels are abruptly interrupted, showing rough, unfinished textures and short instructional etchings in old Kawi script intended for the carvers. The builders entombed their own sacred artwork to save the building, prioritizing engineering survival over their original aesthetic vision. While the massive new base solved the sliding issue, the builders still faced Java's constant violent tectonic earthquakes. To combat seismic shocks, the builders used a mortarless system. They relied on interlocking corbelled joists to connect the hundreds of thousands of andesite blocks. This interlocking design distributes kinetic energy across the structure. It allows the individual stones to shift and settle during a tremor, dissipating the shock across the masonry without fracturing the blocks. Borobudur's survival across 1,200 years is the direct result of this proactive, highly adaptive disaster engineering. For a long time, historians dismissed Southeast Asian architecture as a static copy of Indian templates. However, managing extreme tropical rainfall with hidden drainage and stabilizing a monument on a natural hill required bespoke local solutions. These adaptations prove the existence of a sophisticated, uniquely Javanese architectural language. The builders imported the Buddhist mandala concept, but the physical execution was a product of local innovation. Borobudur is a record of indigenous Javanese ingenuity. It is a megastructure explicitly designed to move and adapt alongside the specific, volatile environment it occupies.